Hello, mathematicians. Today we are looking at Module 9, Lesson 2, which is about multiplying mixed numbers. Hopefully, by the end of this lesson, you'll be able to solve real world problems involving multiplication of mixed numbers by writing an equation to model the problem. So, if you look at Spark Your Learning, it says Aaron paints a large rectangular canvas that measures 2 1/4 feet by 4 1/3 feet. He wants to enter his painting into an art contest. The contest rule says that the area of the canvases must be less than 4 1/3 square feet. Based on these rules, can Aaron enter his painting into the contest? Explain with words or drawing. Well, if I look at this, so my equation would be 2 1/4 times 4 1/3. Well, equals, we're just going to put A for area. If I just do a little bit of estimating here, and I do 2 times 4 1/3, that's going to be, I'm just going to double, so 4 plus 4 is 8, and 1/3 plus 1/3 is 2/3. So that's already larger than 4 1/3, and we'd have to multiply by the 1/4 as well. We also know, based off of our lesson in the last module, that when we multiply by a factor greater than 1, our product is going to be greater than our other factor, so it's going to be greater than the 4 1/3. So no. Aaron cannot enter his painting. Two and 1/4 times 4 1/3 will be larger than 4 1/3 feet squared. Okay, so if we look at the next page, it says Tam draws a logo for her company's website. The logo is a rectangle that is 1 1/3 inches wide and 1 3/4 inches long. What is the area of the logo? It says each unit square shown represents a square with a side length of 1 inch. Use this area model to represent the area of Tam's logo. So it says if we do that, we want to look at B, and it says why does this area model show 4 unit squares? Well, if each one of these is equal to 1, um, we need to have more than 1 because both of our dimensions are larger than 1. So each side of the area has to represent a factor greater than 1, but less than 2. So then it says, how do you show the width of 1 1/3 inches? Well, we need to split 1 1/3. This is going to be the top here. We need to split that into thirds. So we're going to split each side into thirds, and then you would shade all of 1, because that's 1, 2, 3 makes up the whole, and 1/3. So I divide it. Each unit square into 3 equal columns. And shaded for the columns. Because what we're seeing is with shading the 4 of the columns is that this is the same thing as 4/3. So this says, how did you show the length of 1 3/4 inches? So we want the 1 3/4 inches. So again, we need to split each into fourths. And then we're going to shade all of the 1 and then 3. Or as we see, 7/4. So I divided each unit square into 4 equal rows and shaded 7 of them. So it says, how many equal sized parts represent the area of the logo? Well, that would be the double shaded section, which we shade it in 4 this way and 7 this way. So 4 times 7 is 28 equal sized parts. And it says, what is the area of each equal sized part, and how do I know? Well, we split the whole thing into, like, each square unit to 3 sections this way and 4 sections this way. So 3 times 4 is 12, and each one's 1 out of 12. So we get 1/12 inches squared. So the area of each equal sized part can be found by multiplying 1/4 times 1/3, which if you notice, the 1/4 and the 1/3 are our denominators. And that equals 1/12. So then it says, what is the area of the logo? Well, if each one of our pieces is 1/12 inch squared, and we have 28, that means I would do 1/12 times 28. I put over 1. So I'd have 28 twelfths, which 12 goes into 28 2 times, and there would be 4 left over. So I'd have 4 twelfths. So that means we're going to say 2 and 4 twelfths inches squared. So since each equal sized part is 1/12 inch squared, and there are 28 of them, I multiplied 28 times 1/12. So Tam makes another logo. The area of the logo is represented by the purple shading. How many equal-sized parts represent the area of the logo? Well, if we count across here, we have 1, 2, 3. So we would have 3 halves. When we come down here, we have 1, 2, 3, 4, 5, 6, 7, 8, 9. So you have 9/5. So again, I made an improper fraction here. And so we'd have 3 times 9, which is going to be 27 equal sized parts. And it says find the area of one of the equal sized parts. So that's where I take my denominator because that's the length and the width. So we do 1/5 times 1/2, and that equals 1/10. So 1/10 inches squared. This is what is the area of the logo. Explain your reasoning, write an equation to model the problem. Well, if we're going to, we have 27 equal sized parts. 27 equal sized parts, each with an area of 1/10. So 27 times 1/10, 27 tenths inches squared. This says rename 1 1/2 and 1 1/4 as fractions greater than 1. Using this picture, we've already done that. So we have 1 1/2 is equal to 3 halves, because 1 times 2 is 2, plus 1 is 3. And then we have 1 4/5 equals 9/5, because 1 times 5 is 5, plus 4 is 9. So this says use your answers from part D to write an equation to model the area of the logo. So we have 3 halves. times 9/5 equals, well, 3 times 9 is 27. 2 times 5 is 10. So we get the same answer. So remember, when you're multiplying mixed numbers, the easiest way, you can use area models, but the easiest way is to make your fractions, your mixed numbers, improper fractions, or its fractions greater than 1, and then just multiply straight across like you're multiplying fractions. So that is all for today's lesson. I hope that you can now solve real-world problems involving multiplication of mixed numbers by writing an equation to model the problem. And remember, in order to be a math person, all you have to do is be a person and do math.